Happy to be here. And the main topic of today is how MySQL can help you combining SQL with NoSQL. And as Wei Chen said, I head up the MySQL engineering here at Oracle. Of course, we have a whole range of products outside the MySQL server, which is our core product. We have MySQL Cluster, MySQL Workbench, connectors, our enterprise products, enterprise backup, enterprise monitor, and so on. So a whole range of products being developed by this team. I've been with MySQL since 2003, so quite a few years in this business. And before we jump on to the topic, I'd just like to say a few words on MySQL 5.7. MySQL 5.7 will be covered more as a whole by Geir after my talk, but just a few words. MySQL 5.7 is GA. It's been GA for over 6 months now. Today it's our second most downloaded product after 5.6, and it's getting close to 5.6. Many of our customers and users have 5.7 in production already. It's proven to give a lot of gains on top of 5.6. So if you haven't already started using 5.7, I really encourage you to download, get started, and it's a really solid product with a lot of improvements that you will hear about in Geir's and in other sessions after that. I won't say much more about 5.7, except for the few things that are relevant for my topic. Other than, of course, it's again much faster than the previous releases, 3 times faster in the scale-out scenario. So a lot of improvements in just out of the box when it comes to performance on bigger boxes. So we reached a stunning 1.6 million queries per second on SQL point selects with the new MySQL 5.7. So 2 things of relevance for the topic SQL versus NoSQL. The first of all is the JSON functionality, which we introduced in 5.7. It's a new column type, which basically enables you to store JSON documents very efficiently in MySQL. So it's not just about storing JSON as a blob, but it's also being efficiently stored, indexed. You can run SQL on these JSON objects, treating the keys in the JSON objects as you would normal columns or attributes. So it's a very, very powerful tool to work with JSON objects. Of course, you can join them and you can do all the things that you can do with SQL. As I said, index the different attributes and so on so that you can get very efficient retrieval and operations on top of JSON. So that's the one. The other one is our group replication feature, which is not GA yet, but is coming in the fall. And Luis will be covering this more in depth. But the relevance for this topic is that when we're talking about NoSQL and SQL, of course, we don't only want to work with one server. We want to work with a farm or a group of servers. And easy HA is the key element here. So you really want to be able to build a MySQL scale-out solution which has very, very easy HA basically built in. And this is what group replication gives you. Luis will cover the topic more in depth later. But I think the key thing here is that this group replication feature is very well integrated into the MySQL server. So you have InnoDB, you have GTID as well integrated, as well as performance schema to make sure you understand what's going on when you run this feature. Which brings us to today's topic around the MySQL Document Store. So I think we have a video to show here. Mike Zinner, who is the lead of this development, has put together a short video to sort of lead into this topic. So over to Mike, if we have the video.
For over 40 years, the relational model has dominated the database market. On the other hand, the document model has gained a great deal of traction in the past few years, and for many good reasons. We think there is a great synergy in a combined solution. MySQL is now bringing both models together. Today we're introducing a new server feature called the MySQL Document Store. The MySQL Document Store allows developers to work with relational tables and schemaless JSON collections in parallel. To make that possible from a single API, we've created what we call the XDEF API. The XDEF API puts a strong focus on both SQL and CRUD by providing a fluent API allowing you to work with JSON documents in a natural way. It introduces new concepts like X sessions that prepare your applications to naturally grow and scale out. This massive scale-out will be made possible by the new MySQL X protocol. The X protocol is a brand new, highly extensible protocol that is optimized for both SQL and CRUD API operations. It is based on a popular open-source protocol definition language, making it easy to route over the network, leading the way to transparent data sharding and more in the future. The MySQL Document Store is the first step in many we've planned. We think that our plans will change how MySQL is used by developers and DBAs. This work was driven by feedback from the community, and we are looking forward for more feedback from you. Please have a look at the new XDEF API, try it with the MySQL Shell or the new MySQL connectors, and give us feedback. With your help, we can make MySQL a great data store for relational, document, or combined models.
Okay, thank you, Mike. So let's have a look at what Mike just talked about in some detail. First of all, before we jump into that, I sort of want to paint the bigger picture of what we're doing here. As I said, having a document store, having a place to store and manipulate and retrieve your data is more than just a single server. I think a lot of the users, customers in here will have a setup very similar to this one. What you see in the picture is your application, several applications up on the top. You have some sort of middleware in between. We have something called MySQL Router. Others use other proxy things, either homegrown or some other things available out there in the community. And under there, you may have one shard, or if you've sharded, you may have many shards. And within each shard, at least you have some sort of master and a scale-out solution. You may have some master-master setup with DIBD or some semi-sync replication or some other solution. We provide group replication as the recommended setup for having the highly available part of a shard and then scaling out through normal asynchronous replication to read shards. So this is the sort of the generic setup that we are working with and providing more and more support to you to provide. So what we're going to talk about today are these components that we've added with the 5.7.12 release that came out 2 weeks ago. Basically, there are 3 parts to this. First of all, up on the top, you see a red box extending the connectors. So in the first iteration, we have extended a few connectors. We will, of course, support all connectors, and we hope that the community will support all the rest of the connectors down the line. So the old connector is extended with more functionality. The other thing that has been released is the little red dots that you see on each MySQL server. That's a plugin which Mike talked about, which is the X plugin. That provides the new functionality on the server side. And the third thing, which is also very important and new, is up on the right-hand side is the red box, which we will talk about more, which is the MySQL Shell. So in the MySQL Document Store, what's new here in 5.7.12 is, first of all, we base all of this on top of the JSON functionality that I already talked about. That's how we store documents, how we manipulate documents efficiently, etc. And then there are 3 things. It's the X protocol, the new way in which the server or the clients talk to the server. It's the XDev API. It's the new connector support for a new way to write your application programs and talk the X protocol. And The X protocol is, of course, also implemented on the server side through the X plugin, and then we have the MySQL Shell there, which you use to manage it, and you use it to manage the farm, and also you can also program in that. I'll get into that a little bit more in the end. Okay, so just zooming in again on the connectors. So you see on the connectors here, there's a combination of CRUD and SQL APIs. And talking the X protocol, so we opened up a new port to the MySQL server. It's a reserved port for the MySQL server, which then over port 33060 talks to the X protocol plugin. And then we have the MySQL Shell that can also talk the X protocol, as well as the standard protocol to work interactively with this. The X protocol plugin then operates over an interface that we open up already when we did GA of 5.7, but basically through that interface into the server, the core parts of the server, it can speak SQL, it can authenticate, it can do all the things that you can do normally through the standard protocol, but now we have a plugin that can do it. Which is of course interesting if you think even more about it. It opens up the server for anybody to write their own plugin as well, if you have some special things that you want to do. So we've opened up the server basically to be able to do full authentication and SQL from this interface. Looking at the X protocol, so the first thing you ask yourself, of course, is why a new protocol? Why not the old protocol? So there's a number of reasons for that. First of all, the protocol that we have today, it was founded its first incarnation comes back from the late to mid 90s, right? We wrote our applications on the web, or our different kinds of applications, in a different way than we write today. So one thing that it doesn't support is asynchronicity, which is basically in any web development model today. You want asynchronous support. You want things like pipelining, you want things like push notifications up to the server, and I believe Jan will go into more detail about this support level later. The other thing you want it to be is middleware friendly. You want it to be easy, as I showed in that bigger picture, the little routers there, or the little proxies. It must be very easy for them to parse the protocol to do intelligent things, like read-write splitting, like load balancing, other things like that. So it's very easy to have an open and easy to parse API to be able to do that. And of course, when we do this, there's been tons of work in this area historically, so we build this on open standards like TLS, SASL for authentication, and protobuf. We're not going to reinvent the wheel here when we do this new protocol. The other thing is, okay, so why do we extend our API? Why not the old API? Why isn't that good enough? You know, the old API, you would basically write SQL strings, and you would push it to the server, and the server would produce a result, right? And if you've programmed an application, you have your code there to sort of synthesize SQL strings, basically append the string, and so on. It's not a very natural way to write code. So you want an API which is well integrated in the language that you're writing. So you want a fluid API with method chaining, much more natural way to program against your data store. The other thing that you want, especially when you talk about having it being middleware friendly and jump between servers for different work, if you want to read or if you want to write and so on, load balance and so on, you want it to be stateless. You don't want things like, okay, I get a warning and then I have a second pass to go and get my warnings, because in a routed system you might not go to the same server, or you have to ensure that you go to the same server to actually get the warning. Things like that. And again, this is something that Jan will cover in somewhat more detail later. Of course, you can run SQL, but you also have specialized functionality in there for CRUD. More things will come later on, like join support and so on. In this first iteration, we have the basic CRUD support. And as I said, the first release here implements Node.js, Connect2J, and Connect2Net. In a few months, you will see other connectors like Connect2C++ and so on. So what does this look like? First of all, through this new Fluent API, you don't necessarily have to work with documents. So this is how we bring together SQL and NoSQL, for example. You can work with documents through collections, or you can work with the same Fluent API on your traditional relational tables. Here I show examples around the CRUD interface, create, read, update, delete, how that looks like in the two different incarnations, whether you work with documents or whether you work with the relational model. And then lastly, we have the MySQL Shell. This is an integrated development and administration shell. So we want it not only to be a way to just do normal SQL or work with the data, we want it to be able to also do other things that I will just mention briefly. It, of course, exposes the new Dev API. It supports different languages like JavaScript and Python. So you can write scripting directly into the shell. Very convenient in your language of choice there. And then you can, of course, do all kinds of things like configure how you want to do result sets and so on, but there's a lot of support there. But a very important message here is that for the future, this is our one tool to do it all, to manage it all. So if you come back and look at that big picture from the past, we have tons of tools today if you want to sort of do admin on the server, or if you want to sort of provision new nodes. We have utilities, and we have all kinds of things. We want to bring all of these together for ease of use in the MySQL shell. So when you work with this farm or this group of servers that you see here, it's through the shell that you will do it. Here you have to be somewhat into the programming to see, but this is an example of what it looks like in the shell. We have our new tool, MySQL Shell. It will be, by default, it will start in JavaScript mode. You can start it in Python mode or normal SQL mode. If you start in normal SQL mode, it will just be like your regular MySQL client that you have today. But of course, in there, you create your collection. You start adding stuff like in there, and then you can find and sort, and you have a whole language in there. And here you see the fluidness of the language, where you don't have to sort of concatenate these SQL strings to do your work. It's something that fits very nicely into your programming model. So this is how it looks like in the shell. Of course, this is JavaScript, and this is exactly how it would look like in your application in the end. And you see, you don't have to understand anything about relational models, creating tables, or anything like that. You can just connect, get going right out of the box, something which is, and add your documents there that fit directly into your application in the end. So to summarize the MySQL Document Store, we build this on proven technologies around SQL, InnoDB, and replication, tools and technologies that have been around for a long time, stable. We can combine, either you can do all schemaless, you can do all relational, or you can do a hybrid, of course. As I said, you can work with the collections, you can work with the tables, you can work with a combination of the two, whatever fits your needs the best. And of course, it's InnoDB in the end, MySQL. We have acidity and transactions. You have your backup tools and so on. You can make sure that you have integrity in your data. We provide a CRUD interface to our JSON, our document store. So the documents are realized by JSON objects in the system. We've created a modern Dev API. This is our first iteration. So I highly encourage you to get going with this and give us feedback, like Mike said. It will evolve. One thing, of course, on the list is the join support. coming next. We have developed a new and modern, efficient protocol for application development the way it looks today. Of course, we have SQL queries and analytics over JSON documents that's already supported in the 5.7 release. Very powerful tool there. And through this new protocol, we can provide you with transparent and easy HA scaling and sharding. Okay, so let's look at the sessions today. What's new in MySQL? That's going to be Gade. And then we have basically an in-depth of MySQL 7 throughout the day, different aspects of some of the things that I mentioned, some other things that I haven't been talking about, like the optimizer and so on, for example. We'll go into group replication, so you can learn more about that, more in-depth on the document store, and then some security sessions also by Mike Frank. So I hope you stay with us for the full day and learn more about all these things. And I think that was, yeah, okay. So I have a resources slide as well. What we try to do with the document store is really have good documentation out of the box so that you can get going with this right away. So there is very, very extensive documentation. It's full, it's all there. On the shell, on the dev API, on the plugin itself, and then tons of blogs explaining what we're trying to do here. And of course, we have all the JSON information that we have provided in the past since 5.7. Okay, so I think I have a few minutes for questions. You said 10 minutes, but okay. I said 9:30 on. Okay, any questions? Otherwise, I'll hand it over to Geir to jump into the overall things that are new in MySQL 5.7. So the question is, when you run these, when you use these JSON documents, will you have the same ACID properties? Like, yes. So the way it's implemented is that these JSON documents, they are stored as blobs in the InnoDB storage engine. They are structured such that they are very efficient to parse. So actually on insert, you actually go in and find the keys, put all the keys in the beginning, and so it's a binary format which is very efficient. But then, of course, it's just a blob, so you can do all the transactions in SQL that you are used to with these documents. So that's correct. The first iteration of the dev API, I believe we did not put in transaction support. Correct me if I'm wrong, right? But I don't think we have like transaction primitives in there. But those will certainly come down the line to actually expose it through the new dev API. But already through the JSON and SQL path, you have full transactional support. And of course, replication works like normal, your backup works like normal, et cetera, et cetera. Okay, what is NoSQL? We can. I think if you talk to different people, they will think about different things, right? So when we think about it here, it's a few key things. So first of all, it's the way to work with your data without operating in a relational model. Basically a free schema, right? So you don't have to think about creating or thinking about your data model up front. You just put your documents in there, right? So that's the one thing that you think about when you think about NoSQL. And the other thing that you think about when it comes to NoSQL is how you manage scale out, how you manage your sharding, and things like that. Because if you think about doing sharding in a general relational SQL setup, you understand that it's not so trivial to translate your SQL statement into a statement that can run across all shards and get a correct result up in the end. If you go to a document model, that's sort of a NoSQL model, where you basically typically sharding on just the ID, and what you support through that API are just simple CRUD statements or very simple queries, then of course the scale out problem through sharding, etc., becomes much more simple. So in that way, we say that we are supporting a NoSQL world. Does that make sense? Okay, so I got the thank you sign. So was there a quick question there? Or? Right, so what you saw on the slide around the MySQL Shell, basically you start your MySQL server with the NuX plugin. So you basically download 5.7.12, you make sure that your plugin is turned on, and then you can just connect with the shell. You create your collation, you start inserting objects and retrieving objects. You don't have to do anything else. And the same thing if you're writing an application, anything, you just directly get going. You don't have to create any schema in the database or anything like that. Of course, that data that you're creating is instantiated in the table underneath, so you can go in through SQL and manipulate your data as well. But to get started, you just do what I showed you in the shell there, is basically create a collation and you start inputting and retrieving data. Okay? Thank you very much. I'll hand it over to Gail.